Good morning, students. I am NAVDEEP DHALIWAL, faculty of RI College of Engineering and IT, Electronics and Communication Department. So today we are going to understand radar receiver used in the radar system. The most common receiver used in radar receiver, that is Superheterodyne radar receiver. So these are my session outlines. First we will discuss about basics of Superheterodyne radar receiver, and then we have a discussion on uniqueness of superheterodyne principle. There is amplification and filtering at low frequency operation. Then we will also discuss the filter and amplifier design. Then we'll have the discussion on tuning requirements. Then we'll have look on superheterodyne block diagram, and then at the end we will discuss about some advantages and disadvantages of superheterodyne radar receiver. So the radar system consists of transmitter and receiver. The transmitter of radar is less complex to design as compared to receiver of the radar. The receiver of the radar system should able to provide the better performance, should provide the reliable operation, should able to provide the accurate information, and should able to detect the presence and absence of the object along with the amplification of the signal. The basic function of the receiver is to receive the signal from the target in the form of echo signal, amplify that signal so that it can be displayed on the screen. In earlier days, a radar system used in such type of receiver which is used only for the purpose of amplification of the signal so that it can be displayed on the screen. Further data is given to the operator for finding out and detecting the position of or location of presence or absence of the object. But nowadays the modern radar system performs some functions along with extraction of information or amplification, and it also provide data which is used for automatic detection of presence and absence of the object. The most important parameter like we require to consider by designing the radar receiver are nothing but the accuracy, reliability, stability of the operation, and types of waveforms used in system. So on the basis of these parameters, or all these parameters are fulfilled by only one type of receiver, that is superheterodyne receiver. So now move on the next topic, that is block diagram of superheterodyne radar receiver. The superheterodyne receiver performs a main function of amplification and filtering intermediate frequency, which is having value less than received echo signal frequency and interference frequency. So this is considered as one of the advantage of superheterodyne receiver. Because of this, it is possible to design a superheterodyne receiver with low cost. And unfair advantage of superheterodyne receiver is that tuning can be easily done by changing the frequency of local oscillator. In case of superheterodyne receiver, most of the time the receiver do not use the RF amplifier. The function is performed by mixer. So now here the unit mixer is basically used for converting RF frequency to intermediate frequency. There is IF while conversion use required to consider loss in the mixer, and it is defined as the ratio of RF input power to the IF output power. So this conversion play an important role by operation of the mixer. The mixer basically uses silicon contact pin diode because of its non-linear characteristics. The output of mixer is given to intermediate frequency amplifier. Now in case of receiver, in order to avoid or in order to remove or in order to increase signal to noise ratio or in order to remove the unwanted signals, the IF amplifier having similar characteristics to match filter. The match filter perform the function of removing unwanted signal from the wanted signal. It is used for improving the signal to noise ratio of system. So if amplifier in case of radar receiver is designed to perform the same function as match receiver, further the signal is given to the demodulator so that the signal is get modulated and the original data will be available to the user. That means in that case the range or the position is get available to the user. Now in case of modern radar system, most of the receiver use threshold detection. That means in case of threshold detection, the threshold level is not set, and when the system receive echo signal process that level, it indicates presence and absence of the object. Now here duplexer is used. The function of duplexer is to allow the antenna to be used either as transmitter antenna or as a receiving antenna. When the antenna used for the transmission and reception purpose, we require to use a unit that is called as duplexer. So when the antenna is controlled by receiver unit, then duplexer allow the antenna to use as a receiver antenna, and the antenna receives the echo signal along with some noise signal. So in case of receiver, the noise is either generated internally or it may be entered into the antenna system. As the receiver radar system operates at high frequency, so therefore very less amount of noise is get entered through the antenna terminal. Next block is receiver is nothing but RF signal processor. The signal received from the antenna required to be processed so that it can provide information related to the position or location of the object. So the RF frequency or RF signal processing unit is used. Further mixer is used for converting RF input from RF signal processor into the IF frequency with the help of local oscillator, and the output of the IF amplifier, that is nothing but the output of matched filter, is further given to the demodulator. Now here coherent oscillator is used, which is considered as a standard oscillator and represented by COHO. The output of the coherent oscillator is applied to the demodulator unit as well as to SSB modulator, and SSB modulator also receive input from local oscillator, as modulator require two frequencies for modulating the signal, that is one is carrier frequency and another is modulated signal. So that is provided by using the local oscillator and coherent oscillator. The output of the SSB modulator is further applied to the transmitter. So this is how the superheterodyne block diagram works in case of radar receiver. as superheterodyne receiver fulfill all the requirements of the application. Therefore, it's most commonly used type of receiver in case of radar system. Now, these are some advantages and disadvantages of superheterodyne radar receiver. It is a single tube in use for the RF amplifier in transmitter and receiver sources, and it is a simplicity and low cost and excellent sensitivity and much lower conversion loss in detection. And the disadvantage is its gain instability, poor sensitivity, and high receiver noise level.